students. All right, welcome back, ladies and gentlemen, to our next lesson about the biggest topic you will ever learn about, the universe. Now, by way of quick review, I want you to think about yesterday's lesson. And I explained to you how this little guy answered all the questions of the universe. I wonder if any of you remember anything about our space ducky yesterday and what our space ducky taught us about the universe. In fact, I'd like you to pause the video now and have a little discussion about how our little friendly space duck has provided us some useful information about the universe. Okay, welcome back. And now, hopefully, you discussed how our space duck yesterday helped explain the Doppler effect and how the Doppler effect is observed by us in the form of waves. In fact, let's go back to some of the pictures from yesterday with our space duck. And we talked about how as an object, like our space duck, moves through space, the waves, either water, sound, or light, as in this case, it's all squished together, shorter wavelength shifted to the blue end of the spectrum, and in the opposite direction, when an object is moving away from us, the observer, the waves get spread out, longer wavelengths towards the red end of the spectrum. And we talked about blue shift and red shift yesterday, and how in the observable universe, everything seems to be moving away from one another and is getting bigger. And if things are getting bigger today, then in the past they must have been smaller. And that was the origin of the whole Big Bang theory. So we can thank our little space ducky once again for helping to explain that very difficult to understand theory yesterday. Today, we're going to stick with things that are a little bit more easy to understand, because these are features of the universe that we can actually observe today. Even you tonight, you could do some homework tonight. And when it gets dark, look up at the sky. And if it's light, or rather, if the light of the stars and galaxies are not obscured by any clouds, so if it's dark out, but there are no clouds, you should be able to see some of the features of the universe as well. In fact, I'm going to be giving you some interesting features of the universe to explore, even if you don't have a telescope with you. There are some really cool things that you can see up in the night sky that can shed light, on the universe's structure and where we're headed in the future. So enough talk. Let's get to some of the features of the universe that can be explored even by us tonight, if it's clear. Let's begin with the constellations. How many of you have ever heard of the word constellations? Yeah, lots of you. In fact, some of you may even know the names of constellations. Let's see, do any of you know the names of any constellations? Pause the video and let's hear some. Very good. All right, so some of the more common constellations you may know the names of. Well, what are they? Constellations are groups of stars that appear to form patterns in the sky. Now, they really don't form patterns in the sky, but they appear to form patterns in the sky from our frame of reference. You see, long before the invention of electricity and its use in our own homes, and this goes well beyond computers and smartphones and video games before light bulbs were invented in the late 1800s. In other words, for the vast majority of human history, humans have had really nothing to do when the sun set, except dream. Because most people in history, when it got dark, would go to sleep. How many of you stay awake after the sun sets? How many of you at night after the sun sets are busily playing on some device, whether smartphone, computer, what have you, maybe watching TV, etc.? Yeah, and you're using electricity to do those things. Well, long, long ago, for the majority of human civilization on planet Earth, when the sun set, it got dark. There was no light pollution other than maybe an occasional candle in someone's house, but they really don't produce that much light, as you know, as we celebrate birthdays throughout the year. But people, for the majority of human history, when the sun set, had a light show that most of you have probably never experienced. We have so much light pollution today for the last 100 years or so that no one really in our country has an opportunity to see what the majority of humans have seen for all of history. And what I'm talking about is a beautiful sight of the stars at night, lit up bright for all to see. Today, with modern technology and businesses that are open at night, we've got lots of light pollution, which filter out a lot of the stars that normally would be able to be visible in the night sky. But even today, even with our light pollution, you can look up in the sky and see lots of stars. Maybe even 1,000 stars if you were to count them. Much fewer stars, however, than have been visible throughout human history. But stars nonetheless. Now, how many of you have ever played Connect the Dots? If you've ever played Connect the Dots, then you know how to follow with your pencil or your pen from dot number 1 to dot number 2 to dot number 3, and at the end it reveals a pattern. Well, the stars in the night sky don't have numbers on them per se, but some of them are brighter than others. And what people have done throughout history is play the game Connect the Dots. And some of the brighter dots, when connected, form certain patterns in the sky, and different cultures at different times would see different things. For instance, how many of you have ever heard of the constellation Leo? Leo is the Latin word for lion. And here's a picture of Leo the lion. And you can see the image of a lion superimposed on a collection of stars. Now, these stars are all at different distances from Earth. They're of different sizes. We're going to be learning a lot more about stars in the very near future. But from our vantage point here on Earth, some cultures over time have put these stars together and they have imagined a lion in the sky. And constellations change their position from one season to another, and they are visible. And that collection of stars stay together as a pattern from one season to another, and they seem to rise during one season and fall during another season. But imagine not having TV or video games. The human imagination is what it is. People would imagine stories and create entire stories based on these collections or patterns of stars at night. In fact, all of the constellations that we know today originate from either ancient Greek or ancient Roman times when full stories would be made up of the different characters, like Orion the Hunter. Orion the Hunter is a constellation that can be easily seen this time of year if you look at the night sky and notice the three bright stars together in the southern sky. That makes up the belt of Orion the Hunter. And the brighter stars above that are his shoulders, etc. And he is ready to hunt down Taurus the bull, and the whole thing isn't visible here. But beneath Orion the Hunter, we've got a bunny rabbit, and behind him a horse and a dog, etc. But the whole sky is actually made up officially of 88 constellations in the sky. Now, there are some constellations that are visible year round, and I want to point out one of them to you right now. Actually, two of them. Look at this collection of stars on the board, and you might be able, and you might have to turn the lights, all the lights off in order to see them a little bit better. But if you look at these patterns of stars, you might know them by certain names. Let's connect the dots for a moment. Let's connect the dots on this one here. And what does it make up? Well, you might think it makes up a ladle or a spoon or a dipper. This is the Big Dipper. And upside down, pouring into it, if you connect the stars here, is a Little Dipper. The Little Dipper empties into the Big Dipper. Now, the Big Dipper and the Little Dipper are actually only parts of larger constellations, Ursa Major and Ursa Minor. Ursa Major is Latin for big bear. This really is only the back and the tail of a gigantic bear in the sky. I'm not showing you the other stars that make it up. And the Little Dipper is part of a larger constellation known as Ursa Minor, which is Latin for little bears. We've got part of a little bear and part of a big bear, but we know them in North America as the Big Dipper and the Little Dipper. Now, why do I point them out? Well, these groups of stars are known as circumpolar stars. You might want to write that down. Circumpolar stars, which means that they are visible year-round, no matter what season it is, in the Northern Hemisphere. In the Northern Hemisphere, these groups of stars are visible all year long. And there's something special and unique about one of the stars. What might that be? Do any of you know what is unique about one of the stars in these two groups of stars? Well, let me tell you. If you look at these two stars here in the Big Dipper and imagine a line connecting these two stars to this star here, this star is important. This star is called Polaris, also known as the North Star. The North Star is a star that never moves from our perspective here in the Northern Hemisphere. All other stars seem to revolve around the North Star. Now, in reality, all of the stars are moving. We talked about that with the Big Bang Theory yesterday. But from our vantage point here in the Northern Hemisphere, because the Earth is spinning on its axis, it appears as though the North Star doesn't move at all. If you're ever lost in the woods, maybe lost on the top of Mount Tammany at night, you would always be able to see the North Star and know which direction is north. And if you wanted to get home here, we live south of Mount Tammany. So you would go in the opposite direction. If you just walked in a straight line and the North Star was always behind you, you'd eventually get back home. But that's a story for another day. So the point is, different arrangements of stars make up patterns that we can see, and we call those constellations. But that's kind of a selfish feature of the universe because only humans visualize patterns in the sky. There are other major features of the universe that are visible to any living creature, and those are galaxies. Galaxies are, in fact, the major feature of the universe. And every galaxy is composed of billions of stars. Now, in this picture here, you can see a variety of different kinds of galaxies that exist. Scientists love to classify things and group things according to similarities. And so scientists have grouped galaxies into different groups or categories, which we'll mention in a moment. But I just want to point out ours. We live in a galaxy called the Milky Way galaxy. And it's a beautiful galaxy, and I'll tell you why it's called that in a moment. But this is what our galaxy looks like, but not all galaxies look the same. And even looking through an inexpensive telescope that you might have at home, there are some galaxies that you can actually see from Earth. In fact, there are even some galaxies, if you know where to look, that you can see with the unaided eye if you're looking in the right place. Or if you have a pair of binoculars, they're easily visible as well. So let's get back to galaxies. And again, here's an image of many, many, many different types of galaxies that exist in the universe, but we're going to categorize them or group them into three groups. The first group of galaxies are called the spiral galaxies. Spiral galaxies are shaped like a pinwheel, a pinwheel. Now, as you're writing this down, I also want you to draw the pictures and write down the example. So here's a picture of a typical spiral galaxy and a pinwheel. If you're unfamiliar with a pinwheel, maybe we'll make one later on, is kind of like little fan blades with a center, and when the wind blows on it, it spins around. That's what a spiral galaxy does. It spins like a pinwheel. So the Milky Way galaxy, pictured here, is an example of a spiral galaxy. And just in case you were wondering, here we are. Have you ever seen a map where it says you are here to help you navigate your way around a town or a location, maybe a place on a hike? Well, we are here. We are actually located in the outer portion of one of the spiral arms of the Milky Way galaxy. So this is what, oops, golly, what did I just do? So let me get out of there. So this is where we are in the Milky Way. So why is it called the Milky Way? Well, check it out. We are located right here, and in the night sky, and again, this is one of the things that we've lost with modern technology and all the light pollution. You have to go somewhere where it's really, really dark in order to see the Milky Way anymore. I've been to certain places in our country, like Montana, for instance, which is far away from big populations. And when the sun goes down, it really is pitch black. And when it's pitch black at night with no light pollution, you can see so many stars, and you can actually see, as you look toward the center of our galaxy, a band of white that crosses the entire sky, almost as if some ginormous creature opened up a bottle of milk and spilt it in space on top of a sphere that covers the Earth. It looks like a Milky Way. it is so dense with stars that it's almost completely white, a band of white that crosses the sky. That's how our galaxy got its name, the Milky Way, because it literally looks like a Milky Way over the night sky. I would imagine many of you have probably never even had the opportunity to see the Milky Way. Fortunately, not far up the road from us is Jenny Jump State Forest. And at Jenny Jump State Forest, there is an observatory that is open to the public. I think every Friday and Saturday night, you can go up there, and there are astronomers up there with gigantic telescopes that will help you observe different things, including the Milky Way. And up on Jenny Jump Mountain, there's a lot less light pollution than there is in your own backyard, more than likely. So if you have opportunity, take a trip up there. Check out the website first. All right, so the spiral galaxies, one type. Another type are the elliptical galaxies. Elliptical galaxies vary from spherical to disc-like. What do those words mean? Spherical is like a ball. Imagine a beach ball. That would be spherical in shape. Disc-like, how many of you have ever thrown a frisbee? Frisbees are a disc, a flying disc. So one famous example of an elliptical galaxy that you can actually see with your unaided eye, if you look in the right place, is something called M87. M87 gets its name from a famous French astronomer called Messier. And Messier once put together a list of the top 100 cool things to look at in the night sky that you could see with the unaided eye. The top 100 objects. If you want to learn more about astronomy, check out the Messier catalog, and you will have a wonderful place to start looking up at the night sky, because M87 is an elliptical galaxy that you can see without a telescope if you're in a place that's dark enough. If you're in a city, you're not going to be able to see much of anything. But here in your own township, it might be dark enough in your backyard to actually see this galaxy without even having a telescope. All right, that brings us to the third category of galaxies, and they are called irregular galaxies. Irregular galaxies are those that have no definite shape. They're like amoebas or blobs. An example of an irregular galaxy is called the Large Magellanic Cloud. The Large Magellanic Cloud is beautiful to see, but it doesn't have much structure to it, such as an elliptical galaxy or a spiral galaxy. Generally speaking, irregular galaxies might be those that are young, that haven't formed a structure yet, or those that are old and are falling apart. But irregular galaxies, like the Large Magellanic Cloud, have no definite shape. But there is something that we have to talk about that all galaxies have in common with one another. And what do all galaxies have in common with one another? They are held together by a force. Any idea what force that is? Gravity. Yes, gravity is a dominant force in the universe that holds the galaxies themselves together, no matter what kind of a galaxy it is. So gravity is a force holding galaxies together. Gravity, did I say that right? Gravity is a force holding galaxies together. So may the force be with you, gravity, that is, and it's also what keeps us firmly planted on planet Earth. If you jump up, if there was no gravity, you would continue to travel out into space and be lost. in outer space. But thankfully, gravity holds us together. Now, what really causes gravity? Well, it really is very interesting. Matter. The matter in the universe, when it begins to clump together, it clumps together due to gravity. And the more matter that is clumped together, the more gravity there is. In other words, there is a direct relationship between matter and gravity. More specifically, the mass of matter has everything to do with gravitational fields. The more mass there is, the more gravitational force there is. So the more massive an object, the more gravitational force. In fact, you might say, if you look around the room right now and you look at other people, you are all attracted to one another. And you're more attracted to the person you're sitting closer to. It's true. No, not in a romantic sense, but in a physics point of view, because we all have mass. Any object in the universe with mass has a gravitational force. If you and someone else were in outer space and there was nothing else around, your two bodies would actually merge together. You would be attracted to one another, and you would find yourselves in an eternal, perpetual, spiraling dance in space, unless something else flew by and was attracted to you as well. But any object in space that has mass exerts a gravitational force. And so that's why we are held on planet Earth, because the Earth is bigger than us. That's why the Earth is held in orbit around the sun, because the sun is much more massive than us. And it's why our solar system is held in orbit around the center of our Milky Way galaxy, because the center of our galaxy has a supermassive black hole in it, which we'll talk about in another topic, that holds our whole galaxy together. So gravity, major force of the universe. In fact, tomorrow we are going to be performing a lab activity where we're going to use a simple device called a pendulum to calculate what exactly is the gravitational force of planet Earth. So that is our mission for tomorrow. We're going to calculate just how powerful our planet's gravitational force is. But to find that answer out, we'll have to wait till tomorrow. And so until then, I'm going to say bye-bye.